chemistry, relative atomic and relative formula masses are often used, and students are often unsure of the units used with each. So, what unit do you use to represent relative atomic and formula masses? Do you use grams, kilograms, atomic mass unit, or no unit at all? By the end of this video, you will be clear on which unit to use and why. Let's start! Firstly, what is relative atomic mass, and how do we identify it from the periodic table? Relative atomic mass is the weighted average mass of the isotopes or atoms of an element in comparison to 1/12 of carbon-12. It is identified from the periodic table by looking at the numbers beside the elements, and that which is the bigger number, and sometimes written as a decimal, is the relative atomic mass. For example, magnesium in the periodic table has the numbers 24.31 and 12 beside its symbol. 24.31 is the bigger number and also a decimal, and is therefore the relative atomic mass of magnesium. Notice the number in the periodic table has no unit attached to it, therefore it has no unit, and this is because relative atomic mass is a relative quantity, a quantity of comparison to 1/12 of carbon-12. However, that is for relative atomic mass. The number can also be applied to different terminologies. For instance, if you are asked about the relative atomic mass of magnesium, that is 24.31. But if you are asked about the atomic mass, that is 24.31 atomic mass units. If you are asked about the molar mass, that is 24.31 grams per mole. So, for relative atomic mass itself, no unit is applied. Let's look at another one. What is the relative atomic mass of iron? You should obtain 55.84. It is the bigger number and the one that is a decimal as well. Let's try again. What is the relative atomic mass of potassium? The relative atomic mass of potassium is 39.1. Relative formula mass combines all the relative atomic masses of the elements present in a molecule or compound. In sodium chloride, the elements sodium and chlorine are present. The relative atomic mass of sodium is 22.99, and the relative atomic mass of chlorine is 35.45. Combining the two relative atomic masses give 58.44, so the relative formula mass of sodium chloride is 58.44. Try this one. What is the relative formula mass of calcium oxide? In calcium oxide, the elements calcium and oxygen are present. The relative atomic mass of calcium is 40.08, and that of oxygen is 16. Combining the two relative atomic masses give 56.08. Now let's attempt some more challenging ones together.
So let's determine the relative formula mass of lithium oxide. In lithium oxide, the elements lithium and oxygen are present. The relative atomic mass of lithium is 6.941, and the relative atomic mass of oxygen is 16.00, or just 16. In the formula, there are 2 elements of lithium and just 1 element of oxygen. So the relative atomic mass of lithium is calculated as 6.941 times 2 to account for both elements of lithium in the formula. This becomes 13.882. The relative atomic mass of the one oxygen is 16. Combining both relative atomic masses, the relative formula mass of lithium oxide becomes 13.882 plus 16, which is 29.882. Now let's determine the relative formula mass of aluminium oxide. In aluminium oxide, there are 2 elements of aluminium, I see elements of oxygen. The relative atomic mass of aluminium is 26.98, and that of oxygen is 60. The relative atomic mass of the aluminium will be calculated as 26.98 times 2. Again, we multiply by 2 to account for both elements of aluminium in the formula. That gives us 53.96. The relative atomic mass of the oxygen will be worked out as 16 times 3. We multiply by 3 to account for only 3 elements of oxygen in the formula. That gives us 48. So the relative formula mass of aluminium oxide through the combination of both relative atomic masses, which is 53.96 plus 48, which is 101.96. Finally, let's determine the relative formula mass of ammonium phosphate. In ammonium phosphate, I have 3 species of ammonium. If I have 3 species of ammonia, and these are they, it means I have 3 elements of nitrogen and 4 plus another 4 plus another 4, which is 12 elements of hydrogen. All of only you can do this is simply multiplying by what I have inside the bracket with what I have outside the bracket. I have 1 element of nitrogen inside the bracket, multiplied by 3, that's 3 elements of nitrogen. I have 4 elements of hydrogen inside the bracket, multiplied by 3, I have 12 elements of hydrogen. I have 1 phosphorus and 4 elements of oxygen. So let's begin. The relative atomic mass of 1 nitrogen is 14.01 multiplied by 3 to account for with 3 elements of nitrogen. I get 42.03. The relative atomic mass of hydrogen is 1.008 multiplied by 12 to account for the 12 element of hydrogen. That gives 12.096. The relative atomic mass of phosphorus is 30.97, and the relative atomic mass of oxygen is 16. When I have 4 elements of oxygen in the formula, so I multiply this by 4 to get 64. So the relative formula mass of ammonium phosphate will work out to be 42.03 plus 12.096 plus 30.97 plus 64. That gives a relative formula mass of 140.096.
Relative atomic mass and relative formula mass sound complicated, but they're really just reading numbers, counting atoms, and adding carefully. Once you stop overthinking the terminology, it becomes one of the easiest scoring topics in chemistry. For more insight from Sci Insight, please like and subscribe. Stay tuned until next time.